Hello again, everyone, and welcome in the second part of chapter Experimental Techniques about the IGCSE Chemistry. In today's video, we will be covering the criteria of purity and we will be talking about the paper chromatography. We'll talk a little bit about interpret simple chromatograms, calculation of the retention factor, referring to it by RF, and also determining the purity by melting and boiling points. One of the techniques used to separate substances that have different solubilities in a given solvent is paper chromatography. For example, if we would like to find out what are the different inks used as mixture to make the black ink, we can use this technique. So to do that, we'll be taking a strip of filter paper or the chromatography paper and we will place a spot of black ink in it. Actually, before doing this, we will be drawing pencil line, and the pencil line is drawn on the chromatography paper as ink would run into the chromatogram along with the samples, and actually we don't want that to be happening. So after drawing a line using a pencil and putting a spot of the black ink, we will be dipping our chromatography paper in a glass jar which is containing a solvent. So after that, the solvent travels up the paper by capillary action. We can see the separation of the different components of the black ink, which means we can find out what are the different inks used to form our black ink, and we can see different spots at different levels. We can interpret simple chromatograms as follows. So when a substance is a mixture, which is composed from different substances, it will separate on the chromatography paper and show all the different components as separate spots. As you can see here, we can say that the substance X, B, and C are mixtures because they are composed from different spots, or they show up different spots on the chromatogram. A pure substance should only show up with one spot, which means that, for example, A, the substance A or D, are pure substances. An impure substance will show up with more than one spot. Okay, so and from this chromatogram, we can say that the substance X is actually composed from a mixture between substance B and substance C. Okay, you can see this by taking a look on the positions of the spots. You can see that the blue spot here refer to the substance B and the substance C. And the red one here is referring to the substance C, and the purple one is referring to the substance B. So by combining the substances B and C, we can find a chromatogram of substance X. So X is actually a mixture between C and B. We can refer to different substances by calculating their retention factor, because each substance is characterized by a retention factor or a specific retention factor. Actually, the retention factor RF is equal to the distance moved by the compound over the distance moved by the solvent. Let's take this example. So here we have our baseline, which is drawn using the pencil. And here is the spot of the substance we put on the baseline. Actually, after processing our experiment, the spot will move on the chromatography paper. So the retention factor can be calculated by measuring the distance between the baseline and the spot of the substance when the experiment is ended, which means by the distance moved by the compound, which is in this case equal to y. After that, it will be divided by the distance moved by the solvent, calculating from the baseline till the solvent front. The retention factor value is a ratio, and therefore it has no unit. And actually, it's always, or the retention factor value is always less than 1, because it's equal to distance moved by the compound, which is less than the distance moved by the solvent. Purity can also be determined by using the melting and boiling point. A pure substance melts and boils at a specific and sharp temperature. For example, for pure water, it melts, its melting point is 0 degrees Celsius and its boiling point is 100 degrees Celsius. So if the substance is impure, we can see that those values will decrease. And actually, this is due to the fact that the impurities in a solid, they will disrupt the repeating pattern of forces that hold the solid together. Therefore, a small amount of energy will be needed to melt the solid. So the greater the amount of impurities, the lower the melting point. So from a heating curve, if we have an impure solution, we'll see that the melting will start before its actual value, or will start before its actual temperature, and we will be having something which is like this, which means it's not a plateau. Okay, it's something which is increasing. This is due to the fact that the impurities will be having different melting point. Okay, so I hope this was helpful. Thank you for watching and see you next time. Bye for now.